In this video, we're going to look at the difference between ionic and covalent bonds, and then a little bit about how to determine the chemical formula of an ionic or covalent molecule, and how to name these types of molecules. So to start out, it's important to know that ionic bonds are when a positive ion and a negative ion, or a cation and anion, come together to make a bond. And this is when a positive metal ion and a negative non-metal ion can join in a attraction to one another because of their opposite charges. These types of compounds are crystals, and you can see what a crystal would look like. All this means is that it repeats this opposite charge over and over again into this big we call it a lattice, where it continues and there's layers, and these types of compounds are typically solids. So that's what it says down here, that ionic compounds are usually solids. These have strong electrostatic forces. That just means they attract with the positives and negatives, and that causes them to hold together in these crystal structures. So the fact that you have positives next to negatives, and it repeats over and over again, that's a strong force that holds the entire crystal together. And then because water is a polar molecule, these types of ionic compounds can often dissolve in water. Now, covalent bonds are different. Covalent bonds are not with ions. They are usually with just nonmetals that do not have a charge but share their valence electrons in order to have each atom able to fill its valence shell just by sharing. And so it's really more like they're competing for the same electrons. So this nucleus is pulling on both electrons, and so is this nucleus. But in order to have a full shell, they both need to have both electrons near them. So we could say this is probably a hydrogen atom. Hydrogen would be full with 2 electrons because it is on the first energy level. Most of the time, they're still going to need 8, just like what we've seen looking at ions that form by getting up to 8 electrons. These are not always soluble in water, but it depends. If the covalent molecule is polar, meaning one side is more negative and the other side is more positive, then it could possibly be soluble in water, but it depends. And these bonds themselves, even though it's not forming this repeating pattern of a crystal usually, these bonds are pretty strong, and so a lot of the properties that we know of in materials come from covalent bonds. Covalent molecules, however, at room temperature could be a solid, could be a liquid, could be a gas, depends on the size of the molecule and the interactions with other molecules. Okay. So there are a couple of types of ions that we could see in ionic compounds, and I just want to introduce you to what they are before we talk about them. So a main group metal would always be a positive charge, and this is a metal that we know what cation is going to form. So the main group of the periodic table are the S block and the P block. The D block and F block are our transition metals. They don't count as main group. So any metals that appear in the S block or the P block would be considered our main group metals. There are a few in the P block that don't just have one charge though, so there are a couple of exceptions. Our non-metals are the ones to the right of the P block, to the right of the stair step. These have a negative charge, and they only typically will form one anion, so we can usually predict what their negative charge would be. The transition metals, though, the most common ones we'll use will be the D block. These have a positive charge because they're metals and they lose electrons, but they could have multiple different charges depending on what they're bonded to or how they are reacted. Then finally we have polyatomic ions. This beginning here, poly, always means many atoms that are an ion. So basically it's a group of elements that overall has a charge, and usually these are going to be nonmetals and they have a negative charge. So we use these nonmetals groups as our negative ion to pair with a metal typically. Now we're going to look a little bit more specifically at how to actually name these ionic compounds and write their formulas. So we just said a main group metal is a metal from the S or P block on the periodic table. Okay, and we have a couple of rules for these to be named. So the metal always goes first, and it keeps its name. Okay, the non-metal goes second, and it ends in IDE. So for example, fluorine would change to fluoride. Okay, so we get over to our steps. So these are going to be the steps for writing the formula. Okay, first we're going to find the ion charges. Then we will do what's called crisscross, which is just a simplified technique. Then write formula and simplify. Okay, so we'll do step 1 here in pink. Actually, I'll do one example in pink. So let's do lithium and oxygen. So we need to figure out what their charges are. So lithium is in column 1. So that means it loses 1 electron and it has a +1 charge when it is an ion. Oxygen is in the 6th column of group 6A, so that means it has 6 valence. Sorry, the lights went out on me. Oxygen has 6 valence, so it gets 2 more and becomes a -2 charge. Now, when I say crisscross, that means the number that was here with lithium is going to be the subscript for oxygen, and the number that's here with oxygen is going to be the subscript for lithium. So when we write the chemical formula, it will be Li2, the 2 came from the oxygen, O, and then if there was a 1 here from the lithium, we're not going to write it. So the final formula for this compound should be Li2O. And this is because 2 positive 1s are required to balance or cancel out this -2 to get a neutral compound. Okay, that's our first example. The second example we'll do will be aluminum and chlorine. Okay, so aluminum is in group 3. Its charge is +3 because it loses 3 electrons. Chlorine is in group 7, so it gets 1 more electron and becomes a -1 charge. Now when we want to figure out what the compound should be, we can crisscross, that's our second step, and we get Al, and there's an imaginary 1 here from the chlorine, Cl3. So this compound has 3 -1 chlorines, balancing out the +3 charge on our aluminum. Okay, now, to follow up with our example, if we wanted to name these 2 compounds, remember the metal goes first, so I'm going to say lithium, and it keeps its name, lithium, and then the non-metal, the ending changes to "ide", so oxygen is going to change to oxide. Lithium oxide is the name of the compound. For our aluminum one, aluminum is our metal, it goes first, and chlorine is our non-metal, it's going to change to chloride. Moving along, we're going to look at the polyatomic ions, because these are also, they have a known charge, and it's easier to predict with the same type of method how they're going to form the chemical formula. So the ones that I want us to memorize, I'm going to list out. This is just because these are the ones that are the most common, and so it's a good idea to have them memorized. But before that, remember the polyatomic ion is made of many nonmetal atoms and has overall charge when they're grouped together. Okay, so the ones I want you to memorize our sulfate, which is SO4 2 minus. I want you to memorize, let's see, carbonate, which is CO3 2 minus. Another good one is phosphate, and that's PO4 3 minus. You might have heard of that one in biology last year. And then cyanide is CN minus. And then the last one I'll list for you is hydroxide. This one's going to be really important next semester. Hydroxide is OH minus. Okay. So these are each polyatomic ions, and we know this because it has more than one atom. So this has sulfur and 4 oxygens together, and when they're all bonded to one another, they have that -2 charge. This has carbon and 3 oxygens together, and it's got that -2 charge. Okay, just to explain what a polyatomic ion is. Now, when we name these, the metal rule is going to be the same. So metal first keeps its name. Then we get to the polyatomic ion. Polyatomic ion is usually second because it's usually negative. And we will just use the normal name of the polyatomic ion. So we'll look at an example in a second. So down below, let's do a couple examples. So if I wanted to do calcium and hydroxide, then this would be Ca has a 2+ charge because it's in the second group, and I already showed you up above hydroxide is right here and it's got a -1 charge. Okay, so our steps are going to be the same. That's what it says right here. So that means we write out the charges, then we crisscross. So we're going to get Ca, and then the imaginary 1 from the OH is going to go here, and then OH 2. Now, the only thing that we need to do here is we need to show that the entire OH is included, and since there's more than one atom here, we need to put parentheses around our polyatomic ion when we have more than one polyatomic ion. So that's the only step or rule that's important. So more than one polyatomic ion, let's say Pa ion, add parentheses. Okay, so then let's look at one more example here. I'll do this one in pink. Aluminum and nitrate. So aluminum is a +3 charge. Nitrate is a, well, I didn't show you that one actually. Nitrate is NO3 and it has a -1 charge. This one's pretty common, but I tried to put just the very most common ones up here. Okay, so if we wanted to find the formula, we can crisscross, and that means we're going to have 3 NO3s. So to show that, we need to have parentheses around our NO3, and then put another 3. So that means 3 nitrogens, but now 9 oxygens, if you recall. Okay, so this is the chemical formula for aluminum nitrate, with that 1 aluminum from the balance in that charge, and 3 nitrates. Okay, so then let's name these. The calcium and the hydroxide, when we put them together, we keep the name of the metal, and it goes first, and we keep the name of the polyatomic ion, and it goes second. So this should just be calcium hydroxide. That's nice and easy. And then for the other one, we have aluminum nitrate. Okay, now things are going to get slightly more complicated once we get to our transition metals. And we'll talk about the transition metals in the next video, but here's a glimpse of what we'll look at.